Yeah, so we'll start off with how do we handle exceptions in Java. It's like any other programming language. Java has this try catch blocks through which you can handle all the exceptions which uh, occur in your programs. So also exceptions are of different types in Java. So exception, it is kind of unexpected event which might occur when you are running your program or while you are compiling your program, right? So it may disrupt the normal flow of your program. So to take care of these exceptions, you need to use the try catch blocks. As I said, there are two types of exceptions. So in Java, there are two types of exceptions. One is called the checked exception, and these exceptions are Java throws whenever you are writing your programs. So it automatically compiles and then it throws these errors. We have already seen this. So some of the examples are input output exception and also the SQL exception. So when you are connecting to any SQL DB, so that time it will throw this checked exception, right? If you don't remember, then when we were reading the files, so when you were writing this file input stream, right, you're passing this text file. At that time, it was telling you to handle this exception. So we use the try catch block here. We are catching the file not found exception. Also the input output exception. So these are kind of checked exceptions because whenever you are writing your code, right, at the same time, Java will tell you that this exception is going to occur. So you know already that this exception will occur whenever you write this particular code, right? So these are checked exceptions. The other type of exception is unchecked, right? So these don't occur at compile time. This will only occur at the runtime. So whenever you run your programs, this exception will occur. And then you need to take care of these exceptions in your program using try catch block again. Some of the examples are exception, null pointer, then array index out of bounds. So if you are using any particular array and if you are trying to access some element which is not within the range of that particular array, then Java will throw array out of bound exception, right? So these are some of the exceptions which occur at a runtime, and these are called the unchecked exceptions. Okay, so as I said, we can use the try catch block to handle the exception, right? So in try block, we give the code which we expect that it will return some exception, right? So that code will go into your try block. Then catch block, if the exception occur, what you want to do or what you want to perform, right? How do you want the code to behave? If you want to print that stack trace or you want to perform some other action. So that particular action should be mentioned in the catch block. Okay, so that's the usual way of handling the exceptions. Then there are few other keywords which you can use. One is finally, right? So finally is something which will always execute. No matter what will happen in try catch, it will always execute, right? So if there is any code which you want to execute outside of your try catch block, you should write it in the finally block. Okay. Then there is throw and throws, right? So these are keywords which if you don't want to use the try catch block, you can throw the exception directly in the method. Okay, so it must be if a method throws an exception, it must be declared by using throws keyword. Okay, so at the beginning when you are declaring your method, at that point only you can directly throw the exception. So, there are two ways of doing it. Either you do it using the try catch block, or you can do it with the throws or throw keywords, which will directly throw the exception. Okay, so since we have already seen the checked exception, let me show you some other unchecked exceptions in Java. and how do we handle those. So right, so let's declare some methods here, like handle arithmetic exception. So a common scenario for arithmetic exception is in Java specifically is when you try to divide any particular integer by 0, right? So that will throw a arithmetic exception. Okay, so if I say here and I will pass here some number. Okay, so now it will not show you that this is some error because it's not a checked exception. But when you run the program, it will show you that exception. Okay. So for that, we need to handle this inside the try catch block because we know that this might throw an exception when we're trying to run this program. And there is already a class for that arithmetic exception, so you can directly use it. So in this case, I might just tell it to print the stack trace. Okay. Now, okay, so as you can see, it is showing me that dividing by 0, it is the arithmetic exception. So I just debugged it. I should run it. Okay. So this is one of the exception. And then say, for example, if you want to check or you want to handle the null pointer exception. So if I say this purpose will use a string, right? And what I will do is while calling this method, I will pass null here, which is a string, right? So I'm passing null in the string. And then in the try block, I will just try to print the length of the string. Okay, and catch, we will again, all these exceptions are already defined in Java, all these classes. So you can directly use them. Okay. So when you pass null into a particular string, it will throw a null pointer exception. Okay, so these are the stack trace, which means kind of logs which Java will print for the exception it is occurring. Okay, so these are some of the examples of how you handle exceptions. So let's jump on to collections, which is kind of our last topic in Java. So collections is kind of a very important concept in Java. It is widely used across whenever you're writing any program or you're trying to kind of manage particular data inside your program, collections are used, right? So you can store different kinds of data using collections, and you can also manipulate the data using collections in Java. Okay, so it is basically an object which represent again a group of objects, right? So that group of objects could be strings, it could be integers, it could be characters, anything. Okay. Then in Java there is a collection framework, right? So that framework, it's kind of a architecture for representing and then manipulating all these collections. Okay, so there are different types of collections in Java, and all of that forms a particular kind of a framework. So there are different interfaces, and we'll look at how that framework looks like and what are the different types of collections in Java. So as I said, we can manipulate our data using collections, and we can perform all these operations: sorting, insertion, manipulation, deletion. So all of these operations can be performed on your data using collections. Why it is used? So it kind of reduces your programming efforts. It makes it more reusable because it has got all these inbuilt algorithms and data structures, right? So you can directly use them to perform some operations, like, for example, sorting. If you don't use a collection, then you need to write the complete logic um, on your own in order to sort particular, say, for example, some arrays or a particular string or anything, any object, right? So all these and there are other kinds of operations which are already inbuilt in Java, and these are provided by the methods inside these collections. So this makes your life easier when you use collections, and all of the methods inside collections. You can perform different operations using these, right? So it reduces your programming efforts. Also, it increases your performance, right? So when you write any particular code, let's take an example for sorting, right? So you will use different if else loops, for loops, in order to iterate through all the elements. Then you compare each element, right? So all of these will kind of slow down your program or the performance of the program, right? But when you use collections, it is much faster compared to you writing some logic which includes a lot of different loops. Okay. So again, the space and time complexity, which is in Java, right? So that is lower when you use collections. As I said already, that code reuse is part of, advantage of using collections. Okay. So this is one of collections framework hierarchy in Java. Okay. So there are maps, there are lists, queues, sets. Okay, so these kind of forms the collections framework in Java. So list, queue, and set, right? So these are already kind of inheriting or this collection interface, right? So this is an interface. Okay. Um, all of these are extending this particular interface. There is another interface which is iterable. Okay, so through which you can iterate through collections. So that's the topmost in the hierarchy, and then collection is kind of extending that interface, and then list, queue, set are extending this collection interface. Okay. Then inside this list, there are different types of list: array list, linked list, vector stack. Okay. Queues, there are priority, DQ, array queue. Similarly, set, there is hash set, linked hash set, sorted set, and tree set. Okay. And then there is another interface which is called map. Okay. And that is different from all of these interfaces, list or iterable collection, but it is still kind of considered inside the collection framework. Okay, or even though it is not kind of extending the iterable and collection interface, still it is part of the framework. And that map, then there are different types of maps, right? So linked hash map, tree map, sorted map. Hash table also kind of extends this map interface, but it is a kind of not so much used right now. Right now, hash map is better, has got better performance than hash table. Okay, so these are the different collections which is present in Java. Now it is not necessary that as an automation tester or automation engineer you need to understand all of these collections. I would say mostly we use list, right? Sometimes we use set, and then we mostly use the hash map for any particular scenario where we are trying to use collections. Okay, so if you know about all these different collections, you should be good when you're working on an automation framework or any particular automation test suite. Okay, so mostly we'll use array list or hash set or a hash map. So these three things, if you know, then you should be good. Okay. So that's the high level of the collections framework in Java. And as I said, we'll be discussing these three important collections of Java. So the first is the array list. Okay. Now, if we have already seen array, how we declare an array in Java, right? And those arrays are kind of have a static size, right? So you cannot change that array size once you have declared it. But array list, it is a dynamic array. So for storing elements, so it grows dynamically. The size grows dynamically. It is not constant or static, and that is why it is called a dynamic array where you can store any number of elements. Okay. So this is useful when you don't know how many elements you want to store in a particular array. That time you can use array list. Okay. If you already know the size of the array, then or the particular collection or object, you can go with the array. Okay. Now elements can be easily added and removed from an array list, right? So you can add any particular element into an array list, or you can easily remove it also. It can contain duplicate elements. Okay. And the most important part of array list is it maintains the insertion order of the elements. Now later on, when we talk about hash map, hash set, right, there you will see the normal collection, it doesn't maintain the insertion order. There are other collections in hash map, hash set, which do maintain the insertion order, but the normal ones don't maintain. But in array list, it will maintain the insertion order, which means the order in which you are inserting the elements into this particular collection, which is array list. Okay. Now, some of the methods of array list which are frequently used or which you can use, right, in your when you are working with array list. So first is add, right? So this is to insert specific elements in specific position of your array list. And then there is clear, which will kind of remove all the elements from the list. Okay. There is get, which you can use to fetch element from a particular position in the list. There is set to change any existing element in the list. Then remove, it will remove the first occurrence of the specified element. Size, it will return you the size of the array list. And then index of, which kind of returns the index of first occurrence of element in the list. Now there are several other methods which are present in array list, but this is a kind of you can say a basic group of methods which are generally used when you are kind of working with array list. Okay, so let's see how array list looks like and how you can perform some operations when you're working with array list. Okay. So this is how you write array list. Okay. Inside this, you need to pass what kind of object it is. So if it is kind of integer or data type, I may say. So this particular array list, it is part of the Java util package, right? So you need to import this package whenever you are trying to use array list. Okay, so this is how you declare your array list. And once it is declared, then you can use all the different methods, right, which are present. So to add elements into your array list, just use the add method. We'll add some numbers here. Okay, and if you want to know the size of the array list, dot size. Okay, so this will print the size of the array. Now, say if I want to remove some particular element from this particular array list, right? So I can use the index here. Okay, so I will say 2, and then you will see the array list size has gone down once we remove this particular element from the array list. Okay, the size will reduce. Now, other methods are array list dot get, right? So this will kind of return the element which is present in this particular index. Okay. So these are some of the methods. If I run this program, right? So you can see the initial size of the array list was 3. Then when we removed one element, then the size was 2. And then this get method, which is the index first, which is 20, it is returning us the value 20 here, right? So this is how you can play around with array list when you have storing some elements into it, and you can either get or remove or add any particular elements into array list. So let's see on the next important collection, which is hash map, right? So this is a type of map, right? And you can store data in key value pairs, right? Where keys should be unique and the values may not be unique, but keys has to be unique. Okay. Now hash map allows one null key, but multiple null values. Important to remember, because when you are using different collections, you have to take care of these things. Because sometimes you may want to insert a null key, then you use a different collection, right? A null element. But in HashMap, it doesn't allow you to insert a null key. I mean, it allows one null key, but not more than that. As I said earlier, it doesn't maintain the insertion order of the elements which you are inserting into a hash map. Also, although it may not be used frequently, but it is non-synchronized, right? So which means multiple threads can access it simultaneously. So in a multi-threaded environment, hash map is non-synchronized. If you want to make it synchronized, there is a method through which you can make it synchronized, but by default, it is non-synchronized. So do remember that. Now, how does it kind of store all the elements and access it? It uses a technique called hashing, right? So which is a technique where it converts a large string to a small string that represents the same string. Okay, so that is how it represents the values, and it is also able to access those values faster, right? So it helps in indexing, and it helps you to search faster inside a hash map. So that's how it has got good performance over um, other mechanisms in Java. Okay, because of this technique, hashing technique. Now, the syntax of HashMap, it is like this, right? So as I said, it stores in key value pairs, right? So there are two types of elements. It could be different, it could be same, right? So here, as you see, it is string, but you can also define it as an integer string or character string or anything, right? It could be also not preserved key, I mean, data types, not only primitive or any predefined data types, but it could be any other object, a custom object which you have kind of declared in your program, right? So you declare this hash map key and value, and then you declare the name equals to new hash map. These are something called generics. It is not necessary that you declare the generics again here. You can leave it empty. It will automatically consider that these are the generics which is being used in the hash map. Okay. Now some of the useful methods of hash map. Again, you can use the get method to it returns the value associated with the specified key. So whatever key you specify, it will return you the value using this get method. Put method used to insert an entry into the hash map. Then is empty. This will tell you whether the map doesn't contain any key value mappings. Okay. Remove, you can use it to remove a particular entry for a particular key. Then contains key, it will tell you whether a particular key exists in the map or not. Similarly, contains value, it will tell you whether that value exists in the map or not. You can use equals method in order to compare an object with map. Then clear method, it will remove all the mappings from the map. And then entry set, so it returns you a set view of all the mappings which is present in your hash map. And similarly, there is key set, right? It returns you only the keys which is present in your map, and it returns in the form of a set. Okay, we'll see how a hash set behaves, but these two methods, it will return a set view of your mappings and keys. Okay, so these are some of the important methods in hash map. And how do you declare a hash map? We have seen the syntax, but let's try and do that in a real class. Okay, so you can say hash map. Now inside this, we need to pass, say example, we'll say integer, comma string, right? Again, it is part of the Java util package, which you need to import. And I will say languages equals to new hash map. This is our hash map. And if I want to add any particular elements, I will say that particular hash map object dot put. Inside this, I need to define a key value pair. Okay, so our key is integer and our value is string. Okay, so you have to declare it or you need to put the values according to your key value data type, right? So it is integer, so I'll say 1 comma, I want to put a string here. I will say Java. Okay. And I will say Python and .NET. Okay. So I'm adding three languages, and these are Java, Python, .NET, and then these are the keys. Okay. So we can access these values using these keys. Okay. So that's the concept of HashMap. Now, if you want to print this particular hash map, you can do it directly using the system.out.println. Now, if I run this, you will see it will print this hash map, right? So with the key value pairs. Now, some other methods like the contains, right? Contains method, that is contains key and contains value. So I can use the contains key, right? I will pass a key here, say 1, right? So if it contains this particular key, then I will say print languages dot, and I will use here the get method. Okay. So what I'm doing here, I'm checking whether this particular key exists. If it exists, I'm trying to print the value of that particular key. Okay. So using the get method, and I'm passing the key here. So if I run this, you'll see it will print the value of that particular key. Okay, so this is how you can access a particular value from your hash map. Now you can check if languages dot is empty, right? So this will check whether your hash map is empty or not. I put a not condition here, which means I'm checking whether it is not empty. Okay, so if it is not empty, then just print hash map contains mappings. Okay. Since it is not empty right now, so it will print this message. If it is empty, it will not print. Okay, what other methods? So we can look at remove. How do you remove a particular key value pair, right? So I just put a key here. Okay, and I again print a hash map. Okay, so that key should be removed from the hash map. So this is the initial hash map. After we remove that particular key, only two key mapping pairs are present, which is Java and Python. Okay, the .NET was removed from the hash map. So this is how you can manipulate and store key value mappings inside your hash map. Okay, it's quite useful when you are working with collections in Java and you want to quickly access your elements using keys. Okay, so let's move to our last collection, which we are going to see, which is hash set, right? So this implements, as we have seen in the collection framework, the set interface. Okay, it uses internally, it uses hash table to store data. Okay, the most important part of hash set is duplicate values are not allowed. Okay, so you cannot insert duplicate values into hash set. Insertion order is also not maintained here, similar to HashMap. Null values are allowed. It is also non-synchronized, like a HashMap. Syntax is like a hash set. You declare the generic, which is a string, right? The name equals to new hash set, again string. Or you may not also declare this generic. It is not mandatory, or you can declare it. Both ways are correct. Okay. So this is how you declare a hash set and some of the important methods. So add method can be used to add specified element to the set, right? And do remember that it will only insert if it is not present. If it is present, it will not insert. Okay, clear to remove all the elements from the set. Contains, it returns true if set contains that specified element. Size returns the size of the set. Is empty, again, if it is contain no elements, it will return true, right? So these are some of the common methods which is used in hash set. So now let me tell you a scenario and tell me which is the best possible collection to use in this particular scenario. Okay, so say we have a list, okay, and in that list we have got all these different languages. So say yeah, so the different elements like or languages like Java, .NET, Python, C, C++, right? All of these elements are present inside this list. And then there are also duplicates. So Java is twice there, .NET is twice, Python is twice, right? So similarly, there are duplicates. So which collection is best to use here in order to kind of remove all the duplicates from this list? And I just want to print the unique elements in this particular list. So which one is the best collection to use here? So although there are different ways of doing this particular program, but HashSet is the best and the fastest, or it in performance wise, it is the best performing collection when you're trying to remove duplicates from a list. Okay, so if you want to see as an example for our hash set, so let's first declare a string here. Oh, sorry, list here. And then I will add the values. Okay, so Java, .NET, okay, and then I will declare some duplicates. Okay, so this is our array list which contains duplicate values, .NET Python. Are duplicates, so we would just want to print the unique values in our list. Okay, so we'll use hash set. Okay, so this is how you declare a hash set, and then Just use that object which you have created. And what you'll do, so there are two methods. I have not talked about add all. So we have seen add, where you can add, we can insert individual elements, which is string here. But if you want to directly put or directly add a collection into a hash set, that also you can do, right? So you can use this add all method. Okay, it accepts a collection. So I can directly pass the collection here and it will add all the elements from the collection. So rather than adding a single element one by one, you can make it faster using this. Now we can use a for each loop, which is used for collections. So I hope you remember we have talked about for each loop. So this is how you use the for each loop. Okay. So it is a little different than the for loop. So here it is read like for each string. Okay. In this particular hash set, iterate this particular loop. So whatever is you write inside this loop, it will iterate for each string inside this particular collection. So that is how you read this for each loop. Now, once I just want to print all the values inside this particular hash set after we have added all the values from the list collection. Okay. As you can see, it is only printing the unique values, which is java.NET Python. It automatically removed or it did not add the other values which were already present in the hash set collection. Okay, so this is how you use hash set